Okay, solving simple exponential equations. There are 3 steps to this. The first step is to express both sides of your equation with the same base. Okay, that's really important, the same base. Once you've done that, then you can equate the indices and form some sort of equation. Once you've got your equation, the last step is to solve it. Okay, so let's look at some examples. Your first example is 2 to the power of x equals 16. Now, we've got a base of 2 here, so our first step is to get this into a base of 2. So we have 2 to the power of x is equal to 2 to the power of 4, gives us 16. Now that our bases are the same, we can equate these indices. So we can say, well, therefore, x actually equals 4. And in this case, I don't need to solve anything. It's worked its way out already. Same thing here for our second example. 3 to the power of x equals 1 over 9. First thing we need to do is we need to get our bases the same. So we've got a base of 3 here, and we can write this side as, instead of 9, 3 squared. Now we need to get it so that we don't have a fraction here. We've actually got 3 to the power of something, and because it's on the denominator, we can actually make this into a negative index. And so now that the bases are the same, we know that therefore x is actually equal to negative 2. Okay, same here. Okay, we've got 3 to the power of x minus 4 equals 1. Now, how do we get this so that we have the same base? Because here we've got a base of 3, here we've got a base of 1. We usually see if we can go down to the smaller base, which would be 1 in this case, but that doesn't seem to work out. So I need to think about, how actually do I get a 1? Well, when I'm looking and I'm thinking about indices, anything to the power of 0 gives me 1. So in this case, I'm actually going to have 3 to the x minus 4 is equal to 3, so that I've got the same base to the power of 0. And now that the bases are the same, I can equate the indices, so therefore x minus 4 is actually equal to 0. And this is now where I solve. So that x actually equals 4. Okay, let's have a look now at my next example. I've got 5 to the power of 3x minus 2, which is equal to 125. Obviously, looking at 125, I know I can get it down to a base of 5. So I rewrite this as 5, 3x minus 2, which is equal to 5 cubed. Same base, so now I equate my powers. Therefore, 3x minus 2 is equal to 3. And now I solve this equation. 3x is equal to 5. X is equal to 5 over 3. And I can leave it like that. Okay, next one. I've got 9 to the power of x is equal to 27. Now my issue is here that I've got a base of 9 and a base of 27. 9 to the power of, 9 to the power of 1 is 9. 9 squared becomes 81. And so 9 to the power of nothing really here will give me 27, nothing easy at least. So what I actually need to do in this case is convert both of these to a base that's common. And hopefully you can see that both of these numbers have 3 as a base. So I can actually write this 9 as 3 squared. 9 was to the power of x, so that's 3 squared is now to the power of x. And 27 can be written, of course, as 3 cubed. Now this is a power to the power law. When I have a power to the power, I multiply the indices, so this becomes 3 to the power of 2x equal to 3 cubed. Now finally I have the same base, and so what do I do when I have the same base? Well, now I can equate the indices, and so that I get that x is actually equal to 3 over 2. Okay, lucky last one. This is probably one of the hardest ones you'll see. You have 6 to the power of 2 minus 4x, which is equal to 36 root 6. Now, I need to try and equate these powers. I've got a third term here, but there looks like there's something I can do here so that I can get it to a base of 6. So let's work with that. I've got 6 to the power of 2 minus 4x on this side. 36 can be rewritten as 6 squared. And the square root of 6 can be written as, this is multiplied, isn't it, as 6 to the power of a half. That's from my index laws. Root 6 is equivalent to 6 to the power of a half. So almost there. Now on this side I've got my multiplication law, so I haven't done anything with this side yet. But 6 squared times by 6 to the power of a half, when it's the same base and we're multiplying, well, we add the indices. So I get 6 to the power of 2.5 or 2.5. Now I've got the same base. Well, now I can go ahead and equate the indices. Now I'm going to rearrange this so that divide the -4 under and then rearrange this so that you get, there we go. Okay, that's our answer.